Welcome to SQL Bits 2020. My name is Rohit Nayak, and today I'm here to talk to you about network access controls for SQL Database. At a very high level, I will take you through understanding how we enable public connectivity to SQL Database, followed by options to switch over from public to private connectivity, thus ensuring that you are more secure and all your scenarios are contained within the Azure boundary. So let's start by understanding how connectivity works. At a very high level, we have a region. For example, here it's West US. And in each region, we have one or more SQL gateways as represented by the green boxes. Now, each of these gateways has a public-facing IP address, which is where your connections are received. Next, we have the actual SQL Server running in the backend nodes, and this is where your database is hosted. The backend nodes are not visible to the end customer, and they are typically running in the private IP address space for the data center. So let's see what happens when you try to connect to SQL database using your server name.database.windows.net. This will typically result to one of the gateway IPs in the region, and then to a port will be 1433, which is the default port on which we are listening for connections. Now, the mode of connecting where you communicate to the gateway and then gateway proxies your connection to the backend. That's the default mode. So this is what will happen if you say connect to your SQL database from your laptop today. There's, however, another way in which you can connect, which is called the redirect mode. And in that, what happens is the gateway only acts as a lookup to say, your client talks to the gateway and says, hey, tell me the location of my database inside the data center. And the gateway returns a token which looks something like this. It is typically a private IP address and a port range of 11,000 through 11,999. And then the client connects directly to the backend node where the database is running. Now, the redirect method is more efficient for very chatty workloads because you are not going through the gateway for each time for sending the query and getting the results back. However, note that for redirection to work, you need to be able to connect to the entire range of IP addresses for the data center and on ports 11,000 through 11,999. So which typically involves working with your IT security team to open that port range. However, the trade-off is there'll be better performance if you use the redirect mode based on your workload. So that's at the very high level how connectivity works. Let's now look at how can we control who connects to our database. So when we look at access controls for public connectivity, first at a very high level you have this button for allow access to Azure services on versus off. This typically is a very high level control, and all that means is you allow anybody from inside the Azure boundary to connect to your database. And there are specific use cases where this is useful, like Power BI connecting to SQL DB, for example. The second type of access control is where you get a little bit more granular and you specify a start and an end IP address range from which you want to allow connections. This is very useful in dev test scenarios where you want to enable your developer laptop to directly connect to SQL DB. We have a specialized case called VNet firewall rules in which you allow traffic from a particular subnet to be able to connect to SQL database. And I'll explain what subnet is later on, but for now, think of it as allowing traffic from a set of machines within Azure to connect to SQL database. Now we also have another set of firewall rules that are not shown here, which are the database level firewall rules. And these can be configured using tsql. So let me drive home this message of how exactly firewall rules work by showing you what happens or how we evaluate an incoming connection. So if an incoming connection matches any of the VNet firewall rules, these are at the server level. So the incoming connection has access to all the databases on the server. If not, we check the database level firewall, and if it matches there, then it only has database scoped access to the database that the firewall rule is limited to. So for example, here a match was found for just the DB1 database. And finally, we fall back to the server level firewall rules. So if there are no database level firewall rules matched, then we look for a match at the server level firewall. And if none of these match, then your connection is denied with an explicit error message. Let me just show you a demo of how public connectivity works. Switching over. And resume. So for this demo, I have my SQL database here, which I have created in West US. And then I have a client VM, which is just an Azure virtual machine in the East US. And my goal here is to connect from the client VM to Azure SQL Database. So let me show you how that is done over public connectivity. So I'm logged into the VM, and let's see what happens when I do an NS lookup. So clearly here we are being sent to this resolving to the SQL gateway in the region, which has a public IP address of 104.42. Now I can even try to do a PS ping, which is Microsoft utility. And this is another good way of testing whether the network path between the client machine and the gateway in this case is open, and which we see it is. So then we proceed to the next part of actually trying to connect to the server. And now when I try to connect, I get an explicit error message back saying the client with IP address so-and-so, which is the public IP address of this VM, is not allowed to access the server. And to enable access, I need to create a firewall rule. So let me just copy that out. Go to my database server. And then here under firewall rules, I say VM and just add it with the same start and end range. And then when I click save, you'll see that I've now created a server level firewall rule that allows me to connect from the Azure VM in question. So let me just verify this. Let's pause. And as you can see here, now I'm able to log in to the logical master. So that was a quick demo of how public connectivity works. And next we will start exploring how we can move away from this and switch to private connectivity. So before we talk about private connectivity, let me give you a high-level overview of how Azure networking works, because you need that knowledge before you look at private IP addresses, and so on. So at a very high level, we have this concept of a virtual network or a VNet. And the way you can think about it is a series of IP addresses that you can carve out for your usage. So this VNet is 10.1.0.0/16. So /16 corresponds to a bunch of IP addresses where the starting range is 0.0, ending range is 255.255. So this is just networking notation of how we talk about VNets. And you can take the VNet and then split it up into what are called subnets, which means you carve it out into logically separate ranges. So I can carve it out into 3 ranges like this. So 10.1.0, 1.1, and 1.2 for front, middle, and back end subnets. Right? Just an example. So that's how you can group IP addresses based on their function. And then the question is, how can you connect to this? So typically you can connect directly over the internet, or you can connect using VPN or express route. And resume. Next, let's talk about, now that you have context about virtual networks, let's talk about this feature called Private Link. What this feature does is allows you to privately connect to a PaaS service, which is platform as a service, from within the customer's virtual network. So let's take a concrete example of how this will work. So let's say you have your Azure SQL Database as it is today, and you have a VM that is running inside of a virtual network. And this virtual network, similar to as I showed you in the previous demo, wants to connect to the SQL database. Now, the way in which Private Link works is it takes another IP address from that virtual network and then links it to the SQL database. So for all practical purposes, now the VM can connect to SQL database via the private endpoint. Instead of having to go via the public endpoint, now all your traffic goes via the private endpoint. So how does this help you? So you get one private endpoint, which is a well-known static IP address, private IP address for this logical server. You can then move your applications without changing the connection string, because we take care of making sure that in context of the VNet, when you resolve your server, it resolves to this private IP. And finally, you can connect from on-premises using express route or VPNs. So as long as your traffic can reach the virtual network where this private endpoint exists, then you can connect to SQL database. And currently it's in GA for SQL database storage, and many more services are coming. So let's delve deeper into what is a private endpoint and how it works. So private endpoint, you can think of it as a wrapper around 3 things. Number 1 is what is the private link resource, which is what is the PaaS service that you're connecting to. It could be SQL DB, storage, or any other Azure service. Number 2 is it needs a virtual network and a subnet. So where is the IP address coming from that you will use for this private endpoint? And number 3 is about DNS integration. So we use an Azure service called private DNS zones, and this DNS zone is what does the magic of mapping your server name to the private IP address. So let's talk about why this is useful and how you may use it in practice. So we have these connectivity scenarios where you can have the client connecting to the private endpoint in the context of the same VNet. This is enabled by Azure Networking and you don't need any special setup for this. You could also choose to peer a VNet. So this could be another VNet under your subscription in the same or even now different region, because we also have global VNet peering. Third option is by introducing this component called a VNet gateway, you can then have connectivity from on-premises through any VPN or ExpressRoute solution. And you can also use this VNet gateway to have a VNet to VNet connection. So that way you can go cross-region and have two gateways that talk to each other. So now that I've shown you at a very high level the value prop of Private Link, let's go into a demo to understand how to set this up and how it works. So for the purposes of this demo, for the purposes of this demo, we're going to go to the same SQL database that we saw in the previous demo. And let me go delete this. So my VM can no longer talk to this SQL database over the public endpoint. And then we go all the way down here in the server level blade, because remember, private endpoint is set up at the server level. But before I do set this up, let's take a step back and let me show you what a VNet looks like. So we have the client VM here, and it has a private IP address from this VNet. This is called PL demo VNet. And if you look at the address space, I have it is 10.9.0/16, which is roughly 64K addresses. Now I've taken that large chunk of addresses and split it up into these different subnets. So I have one subnet which is 10.9.1, which is where I'm creating all my virtual machines. And then we have something called as PEC subnet, which is where I'll create the private endpoints. So that's the high level network architecture. And my goal now is to create a private endpoint in this VNet. So this client VM can use that private endpoint to talk to Azure SQL Database here. So let's see how to do that. So click on the server, go to private endpoint connections and say you want to add a new endpoint. Now, first thing you need to do is select the group, resource group where the private endpoint will be created. So I know it needs to be in the same resource group. Let's pause here for a minute. And let's resume. First thing I need to do is pick a resource group. So this will be PL demo PERG, which is where my client machine is also there. Let me name it and now very important to see where is it that I want to create this private endpoint. So the private endpoint will typically be created in the same location as the VNet, so which will be East US. Next, now it's asking me for the second part. So I've given it the information about the virtual network and subnet. What is the resource type? So you see all these type of PaaS services have the ability to do private endpoints now. So let's do SQL Server, and then I want my, so I now want PL demo SQL, which is this one. So I've given it 2 out of 3 things. Next, once again choose the VNet and the specific subnet. and it's asking me whether to integrate with the private DNS zone. So here I already have a DNS zone, so it's just going to use that. Otherwise I would have typically created a new one. So let's say review and create, and click on create here, and you'll see as this makes progress, you'll see that it's going to create different types of resources. And we are back, and the private endpoint creation went through. As you can see, it's created a bunch of resources. It has created this demo PEC1, which is my private endpoint, and it has created a DNS zone right here. So let's go to the resources. So let's see what got created so that we understand this better. So as you can see, this is the private endpoint. You go to the DNS settings. It's basically telling you that for your Azure SQL database named PL SQL, I have linked it to this private IP address of 10.90.4. Okay, and let's go back a bit. And if I go into this resource group, I see a few other things that are new that got created. Okay. Pause here. Okay. Resume here, and when I look at the resource group, I see a few other interesting things that got created. So I have now, as I said, a private DNS zone, and the DNS zone has a record in it. Think of it like this is what we look up to do the name resolution. That basically says PL demo SQL maps to 10.9.0.4, and then this is mainly only valid in the scope of this virtual network. So for the linked virtual networks, that is where the DNS zone is implemented. So now that we've seen all that gets created in the portal, let's actually try to log in and see how this changes the picture now. So I'm just going to run the same set of commands that we had earlier, and we'll see how things have changed. So as you noticed, right, I didn't change anything on the VM. My client remained in the same place. Resume, pause. Now that you've seen what gets created when we go through the private endpoint creation process, let's actually go log back into the client and see what happened. So the first thing you'll see is when I do a NS lookup now, it resolves to the private IP address, the 10.9.0.4 address, instead of the public address of the SQL gateway. Next, if I do a PS ping, it's exactly the same behavior. Instead of your traffic going through the gateway, it is going to this private IP address on the particular port 1433. And when I try to connect, voila, I'm just connected to the database using private IP and not via having to go add an IP address in the firewall rule. So, and let me just confirm that. So if I look at where my connection is coming from, it's actually coming from 10.9.1.4, and 10.9.1.4 is the private IP address of this VM. Actually, it won't show here, but yeah. Yeah, as you can see, 10914 is the private IP address of this VM. So that was a demo of how we switch from using public connectivity to using private connectivity. So you just saw a demo of how we switched from using public to private connectivity. And as we noted earlier, what this gives you is you have one private IP address that all your connections go through. Next, let's talk about a couple of features that help complete the loop and also make you more secure. So first, we have something called as deny public network access. So all that this means is you want to close down that public facing connection endpoint, right? So nobody can connect via public. However, to be able to do this, you need to make sure that you have a private endpoint configured and working first. And second, you have the ability to now set a TLS version for the server. So for people who are working in regulated industries like banking and all, this is a big ask over the years, and we have delivered it along with the public network access feature. Quick segue so that everyone understands how this feature works. By default, deny public network access is set to no, which means your connections go through the same set of rules that I showed you earlier, where we check the VNet firewall rules, the database firewall rules, and the server firewall rules. The moment you set this to yes, what happens is all those ways of connecting are effectively blocked, and you can only connect via the private endpoint. So it's very important that you have a private endpoint first, otherwise you will not be able to set this feature to yes. So with that, let's go into a demo. So as I said, now what have we done so far? We have made sure that this client VM is connecting to my Azure SQL Database using private IP address, and we verified that using the various tests I showed you earlier. Now let's close the loop on the public access. So again, I go under my firewall settings, and as you can see, deny public network access is set to no. Now let me just bring up a different server and show you that that is not the case by default. So for example, by default, if you do not have a private endpoint defined at the server level, you cannot set the property at all. So that's a fail-safe to make sure that you do not end up setting this property and losing all connectivity to your server. So now all I need to do here is flip this to yes and hit save. And now I can show you what happens when I try to connect. So here I've opened command prompt on my local laptop here, and let me go just copy out the SQL CMD command. So I'm going to try to connect to this server where we just set deny public network access to yes. Okay, so as you can see, we got an error, which is expected, but we're getting a very specific kind of error that gives us information. It says the public network interface on the server is not accessible. To connect to this server, use the private endpoint from inside your virtual network. So this is how we've given you a knob to turn off all public connectivity. And when you do so, you also get a specific error message saying that you are not able to connect because this is off. And so that was the demo around deny public network access. I've listed a bunch of resources and videos on YouTube that will take you through the same material in more detail. Thank you for your time and hope you have a wonderful rest of the conference.